as defined by the Digital Twin Consortium, are virtual representations of real-world entities and processes, synchronized at a specified frequency and fidelity. Digital twins allow us the opportunity to simulate technology scenarios and optimize business decisions using real-world data sets within the relative safety of virtual spaces. Digital twins are also a cornerstone of the metaverse, a quickly emerging virtual shared space that is already influencing the digital economy. Digital twins are now recognized as an essential enabler of digital transformation. It's for these and many other reasons that digital twin utilization is projected to exceed $115 billion across all major industries by 2035. At Digital Twin Consortium, we work to capitalize on this momentum by driving awareness, interoperability, and development for digital twin technologies. The goal? To spark innovation, accelerate digital twin adoption, and to enable a better, smarter world. This includes helping to positively impact how manufacturers plan and build products, how cities and buildings can be made healthier, more sustainable, and more efficient, with transportation corridors that are less congested, how energy grids are designed or upgraded to be more resilient and secure, how healthcare and life science systems are developed, validated, and deployed, how disasters are predicted and emergency services delivered, how the agriculture value chain is improved by maximizing crop yields and efficient use of water and fertilizer to make farming more sustainable from field to fork and ocean to plate, and how renewable energy projects may be best implemented. We're influencing new technology-driven trends and initiatives that include supply chains and autonomous operations, blockchain implementation, and the push for net zero carbon footprint reduction. And we actively promote a collaborative cross-industry ecosystem, transformative business outcomes, the identification of development gaps via reference and maturity models, the establishment of interoperability requirements, frameworks, and open source code, the development of best practices, policies, standards, taxonomies, use cases, and more. That's how we're accelerating innovation and driving adoption, with our founders alone investing more than $30 billion. And we're just getting started. Learn more today, whether you're a vendor, enterprise, academic, researcher, or government agency. We invite you to join our ecosystem of world-leading technology experts.
So we will have a quiz at the end of the presentation on that information. My name is Dan Issacs. I'm CTO and GM of the Digital Twin Consortium, and really appreciate the time. Thank you very much for the ARC Advisory Forum to be able to come and present and just introduce a little bit about what Digital Twin Consortium is. We constantly are going out and hearing that we've never heard of the Digital Twin Consortium. We can't believe that. We were founded about 4.5 years ago by Microsoft and by Dell, and then also ANSYS, as well as other organizations. And we started with about 50 members, many partners of Microsoft, Dell, ANSYS, but also startups, also the innovators, the ones that really want to make a difference, universities around the world now. So there's two key themes I want to leave you with. Number one is digital twins are basically being adopted across virtually every industry. I haven't found an industry yet that can't benefit from the value of a digital twin. And then we've continued to expand and increase our scope to look at those key attributes, those key elements of digital engineering. So we look across advanced model-based development, model-based system engineering, but also looking at it from the standpoint of the data, the lifeblood of a digital twin, being that data. What is that composed of? How does that start? How does that data thread between the different phases of the life cycle of a digital twin? So looking at, again, the digital thread, which is really a misnomer, and you saw that from several of the presentations today. It's not just a thread, it's an information highway that runs bidirectional in nature through those different phases. And that's where the real value of the digital twin comes into play. So those are two key elements. Here you can see now, fast forward 4.5 years, BP is now on our steering committee. Dell and Microsoft continue. We've had another company from Sev1 Tech bringing forth with their DoD. They're working directly with NASA, with LSU across multiple areas. And then you can see a combination of other companies across the world. where we have NTT, we have NEC, Northrop Grumman, DNV, Eli Lilly. We haven't announced it publicly, but Pfizer has now joined the consortium, and we're in talks with several other biopharmaceutical companies. It's really made up of, as I said, the innovators. So it's the solution providers, it's the researchers, the universities, the academia, local government, where mandates, directives, regulations, as we've seen, especially with AI coming into play, but it's about the end users as well. And so with that diverse collection of levels of expertise, we can now bring across all these different areas this collective intelligence, this collective wisdom to bring forward the innovation and the thought leadership. And we look at it not just on the vertical level, but we also look at the horizontal level, those foundational elements, security and trust. Trust bringing in reliability, resiliency, bringing in safety, functional safety, and as well privacy. So across the board. So we're structured in terms of different working groups, and these are just some examples of use cases. In fact, the examples you saw in the video, those were all taken from members that are working in those areas. And that was 2.5 years ago, believe it or not. So now fast forward and look at where we are today. Look at the different types of use cases represented within our membership. And I couldn't have shown this slide about 1.5 years ago. These are the end users now that are coming and joining this consortium, these different areas. In fact, I didn't just pick these pictures just because of the images. Name one of these and I'll tell you the member that's working on it. And that's pretty impressive when you think across the industry and the adoption that we're seeing and what we're helping to really drive and accelerate that adoption throughout the ecosystem. We're structured in terms of member-driven working groups based on those verticals. Right in the middle, you can see that horizontal, collaborating across the different working groups as well. And they're actually made up of the leads of those different working groups to bring that diversity, to bring that selection and capabilities forward. And that's a key point. We heard about these capabilities in every single one of the presentation. Capabilities, interoperability. You can see this echoed throughout all these different areas. And we developed these frameworks, and then we published them onto our site. In fact, several members we found, they were already using our deliverables. They were already seeing the impact that we were making as a result of that. And so what we developed was a technology showcase, a reference library of use cases and case studies that demonstrated and showed that value across the different phases of the life cycle of the digital twin. And those are all published on our site. You can go and take a look at those. And what we did was we based it on specific work product from our members. So we drink our own Kool-Aid. We use that, we understand it, we learn from it, and then we build and we continue to improve it. And one of those areas, in fact, you'll hear from one of the panelists, they originated this concept of a capabilities periodic table. So put this all together and you have this composability framework, starting with the business maturity model, leading into a capabilities periodic table, which really gives you a starting point. And we've heard this from outside companies. They've said, look, we've been able to use this in a way that it identifies where our strengths are, where our weaknesses are, and what areas we need to focus on. So think about it in terms of not a technology specific or looking at the data you have, but look at it in terms of what job am I hiring the digital twin for? And then what would that digital twin's resume look like in terms of those capabilities? So bringing this together, and again, it's thanks to the work and the origination based on a meeting that member, our chair originally of natural resources, had with his end customer, and that's Peter Van Schalkwijk. You'll hear from him on the panel later today. Look at it in terms of being able to bring together these in a very familiar format and understand this in that context. So take a periodic table, replace the elements with these capabilities, then understand from those capabilities, what are the optimal technologies to be realized from that? Then look at the data. Do I have the necessary data, or can I bring the precision, the accuracy forward by using synthetic data? Then look at that implementation from there. So we created that entire workflow. Every one of our reference library use cases shows that. And we don't just stop with our membership, we also bring this forward from a regional branch perspective. So we have members that have direct ties, and these are all approved through our steering committee, to the academia in their area, to the large industries, to the government, to the innovators, the incubators, the accelerators. We have them across the globe, as you can see, virtually every major continent, almost every country in Europe, in Japan, in Korea, Australia, New Zealand, regional branch organizers, India, we just brought on Africa, Indonesia's coming next, North America, South America. So we have this incredible network that we can now bring together in this collective wisdom. Don't reinvent the wheel. We'll give you the wheel, and you can accelerate your adoption. And that's exactly what we're seeing. But we don't stop there. We now have liaisons and relationships, such as with ARC. And we have over 20 different liaisons working together, OPC Foundation, Industrial Digital Twin Association, Open Health Systems Lab. I mean, we continue to build these out. And really, the interesting aspect is most of these came from our members. They said, we're working with this organization. You really should be a part of it. We should figure out what we can do. So the collaborations really open up, not just within the members, not just within the working groups, but across these consortium, and evidenced by here today. Thank you, Peter. So again, as I said, we've now expanded our scope to incorporate those key attributes. This came out of a specification from the Department of Defense. Looking at it in terms of digital engineering, what are those key attributes? What are those areas you need to be focused on? If you want to bid on any of these contracts, you need to be able to show me not how you're looking at it from PDFs and Excel files like this, how we're passing that information in a digital environment. Digital model, and it starts right at the requirements level all the way through, as you can see, through the business model, through the architectural, all through the life cycle. And the corollary to that is the digital thread, as I was saying. The data that's thread between the different phases. And you look again from requirements analysis all the way through training even, development, operational, across that entire spectrum. How do you realize those two elements? You realize them with the digital twin. And what we've been hearing today, and this aligns very well with the digital reality ecosystem, and that key point is now we bring in the digital twin, but we bring that forward in terms of the evolution of the digital twin. And we were at one of our member meetings. We run quarterly member meetings. One of the member meetings, we started seeing these coming forward. Here's how we're using multi-agents in this approach. And we're not only developing, but we're deploying it. It's in production today. So the benefits. So we talked about that. The use case of digital twin, multi-agent, generative AI systems to add even increased value to what digital twins provide today. Here's an example from one of our steering committee members. Another example in terms of software-defined vehicle. Look at that, over 70% improvement in terms of the testing for that. And then we have another example here, and this is coming out of XM Pro, the company Peter Van Schalkwyk had founded, driving this area, looking at it from the agent perspective, looking at it from a multi-agent, but wrapping these rules of engagement around that. And he'll talk more about that in the panel. And so looking at that, bringing together this collective intelligence, how can we work together, not just within the membership, but expand these opportunities to now bridge this? And just like digital reality ecosystem, that incredible ecosystem that's being built throughout, we look at this across different areas. And here's one example. This is working with OPC Foundation, with SESME, with the Industrial Digital Twin Association. We built this out and brought it out as a digital product passport. And you're going to be hearing more about that in the coming months. Looking at this, powered by these different areas, including Industrial Digital Twin Association, all different areas throughout, and then give a specific example, use case, demonstrate that, showcase that. And that's very well in line with the Open Asset Digital Twin. Working group objective, as you can see, continuing forward, and we're right at the beginning of that, working together now that we have this liaison from bringing forward this thought leadership, this innovation, through the collaboration of our members, other organizations, to establish that leadership and continue to grow and build that community. Thank you very much.
Thanks very much, Dan. So our next speaker is Pedro Vieira from Petrobras, and Pedro is the digital engineering manager. Join me in welcoming Pedro.
Where's the presenter? Oh, thank you. Hello. Oh, it's working. Good afternoon to everyone. I'm going to present you a view of Petrobras around the word digital twin, or the concept of a digital avatar. This was presented in the last OTC, the Offshore Technology Conference in Houston last year. And I'm going to give you a brief view of the framework, okay? This is a disclaimer. Yeah, I hope you read it. Okay, this is a collaboration presentation. So many people from Petrobras collaborated in it. Here are the names. What is the problem? The problem is that everyone wants an AI, everyone wants digital transformation, everyone wants a digital twin. It's everybody wants to calculate how many miles they can make with gas using ChatGPT or something like that, instead of just doing the maths, because AI is so popular and digital twin is so popular. This is good, but this is also a problem, because are we talking about the same concepts or the same things when we talk about digital twins? Or am I referring to one concept and you are referring to other one? That's the main problem, okay? So we have project twins, we have construction twins, we have equipment twins, and all this is digital twin. We have run this survey in Brazil to ask what digital twin is for you, okay? So simulations, emulations, smart schematics that are P&IDs, PFDs, equipment twins, 3D modeling, or the connection to other systems such as ERP or electronic document management system or planning and control, etc. So we grab all these answers and we put them into 4 domains in a framework that I'm going to show you, okay? And we are proposing calling it, instead of digital twin, a digital avatar. Why that? Because a twin, nothing is more different than 2 twin brothers, okay? We do not want a twin. We do not want a digital asset different or living a life different from our physical asset. We want them always connected as the Avatar movie, okay? So just one consciousness and 2 bodies. That is the concept that comes from the Sanskrit thousands of years ago, meaning that a manifestation of a god was called an avatar. It's not another god, it's the same god, just another manifestation. This is an avatar. And this is why we must have our digital asset always connected to the physical reality. And I must remember you, the presentation Michael did just this morning, reality first, okay? So we have a kind of a priority. A priority is reality first, and the other is an avatar. Okay, these are the 4 domains I mentioned to you. I'm going to present you these 4 domains, some products related to these domains, some pillars, and the North Star. That's the main slide, okay? So the first, do you have a laser pen here? Yeah. The first domain is the spatial domain, okay? So when you talk about 3D modeling or laser scanning or something like that, we are talking about the spatial digital twin or digital avatar, okay? The other one is the physical-chemical domain. It's related to the process plant. It's related to the chemical plant and the operation and maintenance of that plant, okay? So the operations of the chemical and chemical process, physical process, is the chemical physical avatar or digital twin. The other one is the in-time or real-time information. This is also referred as digital twin. It's not the process plan is not about simulation or emulation, but it's real-time, the physical, what is really happening now in the physical plant. And the other one that we called characteristics, I don't like that name, but it was, it's a kind of a miscellaneous or connections to other systems, okay? So inside these 4 domains, we have some products. For example, I said you, 3D models are spatial domain, 360 photos are example, the point cloud are examples of spatial digital twin. Physical chemical, we have smart schematics. There is no dumb P&IDs. We need P&IDs connected to the plant that makes sense with the chemical and physical plant. The other one is simulations and emulations. So, for example, we have process simulations running in parallel to our physical plant, or we can have our automation system emulation, that is a copy of the automation system running in the digital asset. This is simulations and emulations. Also, we have the equipment twins. There's very, very important connection, especially for critical equipment in our physical chemical plant, okay? Such big equipment or turbines or generators for our production platforms or refineries, for example. So, spatial domain, physical chemical domain, and in-time, real-time domain that is, for example, IIoT, asset management systems are also referred as digital twins. I have a digital twin. This is an asset management system. Is it a digital twin? Yes and no. Yes, it's a part of a digital twin, but it's not the whole digital twin. IIoT, also referred as digital twin. I have a digital twin layer. What is it? Is IIoT. Okay. PI and information real-time systems, and advanced control and real-time optimization, okay? These are in the in-time or real-time digital twin domain. And the last one is connections or characteristics or miscellaneous concerning the digital twin, but also important. For example, the connection to the electronic document management system, the planning system and control system regarding projects, the issue system that is very, very important for history, and the ERP system. All these examples of systems or products connected to the 4 domains, we call this whole set a digital avatar, or if you want, a digital twin. And we have 3 pillars, or pillars. The first one to have this set is data standards and governance. Without data standards, it's impossible to have a digital twin, okay? It's another one, it's the IT, ET, that is engineering technology, and OT, that is operations technology, convergence. So now we have IT inside our OT, and we have OT inside IT, and ET inside IT and OT. So IT takes care of, I don't have to explain you, IT is very known. OT is automation and instrumentation inside the plant. And ET is digital engineering in general, or assets in general, okay? So I can represent my process plan in terms of information, that is IT, operations, that is OT, and assets, that is ET. And the other pillar is scalable IT. So if I don't have a scalable IT, it's impossible to have a digital twin. And finally, we have the North Star. There is digitalization, automatization, modularization for reusability. Without that, we will have to rebuild our digital avatar, our digital twin from scratch every time for every new project, okay? So, with these 4 domains and these products, with these 3 pillars and this North Star, we say this is the Petrobras proposed framework for us to know about what are we talking, okay? I have some minutes now. Okay. Just for you to have an idea, we have a very specific problem. We, as the world, have a very specific problem about the use of digital twins or digital assets. Nowadays, in one of our production platforms in Petrobras, we have over 30 million attributes in our database of our digital asset. This is what I'm talking about. Almost 20,000 instruments, 40,000 pipe runs, 370,000 structure pieces, etc. The problem is, I'm not going to do this. The problem is, when I hand over this digital asset for an EPC, in Petrobras we make the conceptual and basic design until the feed phase, the front-end engineering design phase. So we hand it over to an EPC for the executive design, construction and assembly, commissioning, and startup of the plant. When we hand over the digital asset for the EPC, since we don't have a data standard for engineering, maybe if you are lucky and the EPC uses the same solution for the digital asset as we use, it's okay. If not, they must remodel, rebuild the digital asset from scratch, losing consistency, losing completeness, and scrambling all our database, okay? That's the first bad news. The second bad news is the EPC must hand it over back to us at the end of the construction. And imagine it goes 3 years fixing the database they scrambled because there is no compatibility, and after all that, they scramble it all again to hand it back to us, losing completeness, consistency, and we have a kind of a useless digital asset after all. Okay, that's the problem we have. So, summary, the digital twin is product-oriented and the digital avatar is asset-oriented. The digital twin replicates a product. It was built for manufacturing, not for oil and gas industry. And digital avatar is about enhancing the asset capabilities. And so, digital twin focus on complex behavior and individual behavior, and digital avatar talks about the system, okay? So, these are the differences. We can use digital twin, no problem, since we know what are we talking about. This is the project cycle. I won't go inside it and go to the conclusions. The digital avatar concept creates a common ground for debate within the industry, okay? Because when I presented yesterday the priorities of Petrobras for the next years concerning the digital asset, I used this framework to say, I'm talking about equipment twins, smart schematics, and 3D modeling, okay? So it's very, very clear for everybody what I am talking about. It provides an implementation framework or representation layers, enabling technologies, pillars, and guidelines, may be used to manage the digital products. It serves as a starting point for companies starting the digital avatar implementation, is a path to implement the concept and expand the concept of digital twin. So this is our framework, what we proposed in OTC, and what we are proposing now, just to have our discussions based on a very clear concept what a digital asset is, what we call digital twin or digital avatar or anything. What I can call chair, I can call chair table and table chair, no problem. But since I give a name to something, I must be consistent with that name. That's the message, okay? That's all. Thank you very much.